Hello everyone, I am Surendra Jain, Master Teacher of Mathematics in Vedantu. I am presenting you the solutions of JEE Advanced 2022. Right now I am discussing paper 2, question number 14 of MCQ type. This question is based on differential equation, actually a direct question on linear differential equation, and you can see its integrating factor will be e raised to the power 12x because it's a direct form of linear differential equation. This is coefficient of y is 12, so function we will consider this as 12 and its integral with respect to x will give integrating factor. So solution will be y into e raised to the power 12x is equal to integration of e power 12x into cos of pi x by 12. Now this thing is little tricky because most of the students do not remember this result. In JEE once also they have asked, although there was alternate method for that question, but here we have no option but to use this formula, or you have to derive it in the exam. Okay, right now I am going to use that result. It is actually e raised to the power 12x upon this coefficient of x here, not pi, it is x, and 12 square plus pi upon 12 square, and in the bracket it would be 12 into cos of pi x upon 12 plus here it would be pi upon 12 into sine pi upon 12x. There are many methods to derive this. You can use complex number, you can use direct integration in which I comes in terms of I once again and use that to get this result. Use of differentiation can also be done to find this result, and this plus c. Now here this 0 at 0 value is 0, so I think c will be equal to, this will become 0, it will be minus 12 upon 12 square plus pi upon 12 square. Okay, this sign will become 0, this will become 1, so this will be my c. So if I write y, it will become, you can check, 1 upon 144 plus pi upon 12 whole square. In the bracket we will have this e power 12x I have cancelled. In the bracket we will have 12 into cos pi x upon 12 plus pi by 12 into sine of pi x by 12. Okay, and I think I can write minus 12 e power minus 12x here, because this c which we obtained, okay, if I write it here, okay, this 1 upon 144 plus pi upon 12 square will go common, and minus 12 can be written inside the bracket, and this 12 power, e power 12x which I am dividing, it will be coming like this. So this is what we are getting as the solution. Now question is whether this function is increasing or not. Okay, now if it is increasing or not, I think dy upon dx will determine whether it is increasing or not. Please see, dy upon dx will be 1 upon 144 plus pi upon 12 whole square, and in this bracket we will get 12 cancelled, minus of sine pi x upon 12. Okay, and here we will be getting plus pi square upon 144 into cos of pi x by 12 and minus minus plus 144 e power minus 12x. Now one very interesting thing, this function is defined for all real values. In fact, there is no problem with this solution if we take domain as all real number. Now if this function is to be increasing, then this dy upon dx has to be positive throughout. Which is positive, you can check for x is equal to 0 if I put, okay, but please listen carefully. As my x becomes very large, okay, very large, this term e power minus 12x can be ignored, or you can say it will have very less values. So in that case you can check wherever my sine pi x by 12 value will be big in magnitude, or just let me take one example. as x becomes very large, and because sine pi x by 12, cos pi x by 12, they are defined for all x belongs to R, and they keep on moving between 1 and -1. So when x will become very large, even then I can take sine of pi x by 12 as equal to 1, or maybe some large value, you can say large means 0 to 1. Okay, so that it becomes negative. Now if this is 1, cos will become 0, and you can check my dy upon dx will become negative, isn't it? So what we have proved by doing all these things, that it is neither increasing, it is nor decreasing, because it is, its derivative is positive also, its derivative is negative also. That is one thing. I think D option is also not true, because of this, 12 e power minus 12x, it cannot be periodic. So I think there is only one option that remains, that is C. It has to be true, otherwise there will be no option that is true. Let us see if this is true or not. What it is saying, it is saying there exists a real number beta such that y is equal to beta intersect the curve y is equal to yx. Y is equal to yx is this curve. Let me write this as equation number 1 at infinitely many points. To prove that, I will once again use the same logic. Please see, we got answer as y is equal to 1 upon 144 plus pi upon 12 whole square into, this was 12 cos pi x by 12 plus pi by 12 sine pi x by 12, and then I think it is minus 12 into e power minus 12x. Okay, now please listen carefully. If I take x very large, s becomes very large. I'm not saying that you ignore this term, but I'm saying it will take values that will be very, very small, isn't it? E power minus 12x will be almost 0. Okay, then this function y with that impact, or you can say effect of cos and sine combined together, will be, oscillating about that line y is equal to 0. Okay, what I'm saying, then this y will oscillate about the line y is equal to 0. It will take y equal to 0 value also, it will go positive, it will go negative, and it will not be for one or two values. It will be, it will keep oscillating for infinite values of x. So it will oscillate about y is equal to 0. So it will cross this x-axis or y is equal to 0 at infinite points. Not only this x-axis, in fact, if you raise this value of y from 0 to slightly smaller value, slightly bigger value, you can say, then also we can expect this curve when x becomes very large to cut that line y is equal to beta, which they have given in the option number C. So they are saying there exists a real number beta such that line y is equal to beta intersect this at infinitely many points. So this is true. In fact, I have already shown you that one of such beta can be 0, but there will be many infinite many beta for which this option will be true. So this completes the solution of this question. Thank you so much. Take care and stay tuned for more such solutions. Bye.